Okay, this is Geometry, Section 10.1, Areas of Parallelograms and Triangles, on page 725. Oddly enough, we're going to begin this particular section by reviewing a couple things. The first thing is special right triangles. Okay, so this is a 60-degree angle. That makes this one a what? 30. Okay, so across from the, let's say the 60 is a 4. Okay, and so can we find the other two sides based on this information? This should be a review. How do we find this side?
Divide by this, no, not me.
Divide by what?
Square root of
We
3.
divide by the square root of 3. And so we rationalize it and we get this. So we get 4 square root of 3 over what? 3. Okay, so now to find for the hypotenuse, which is right here, what would that be?
You multiply
No.
by square root of 3.
No, you
multiply by 2.
Thank you. You multiply this by 2 over 1. Excellent. So this is the side right here, correct? And then we multiply by 2, so we actually get 8. That's an 8 square root 3 over 2. That's an 8 square root 3 over 2. You probably can't read that very well, can you? But it's 8 square root 3 over 2. Do you want me to erase that and try better? Try better. The hypotenuse is,
Why would it be 2?
oh, did I say 2?
Yeah.
It's 8 square root 3 over 2 is the hypotenuse. Okay?
No.
Where am I getting what?
It'd be 3. Where would you
The
on the
denominator.
bottom?
Why do I keep doing that? If it was a, just out of curiosity, if it was a 2, could I cancel the 8 and the 2?
Yes.
Okay, all right. All right, let's try to draw this triangle a little bigger. It didn't end up much bigger, but this is a 45, right? Okay, so let's say this is 7, okay? What is this side?
7.
And what is this side?
7 square root 2.
Okay, 7 square root 2. Much easier to deal with a 45, 45, 90 than a 30, 60, 90, correct? So this is a 30, 60, 90 triangle, and this is a 45, 45, 45. Now we're going to have, we're going to have some problems that refer back to this. So I wanted to remind you what that was. Okay? All right, so today's lesson is really about the area and perimeter. We're going to do some perimeter, area, perimeter of a parallelogram and a triangle. Okay? Now, I better not use a symbol since I didn't use a symbol on a parallelogram. I think most of you can tell me what the area, I mean, the perimeter is just around it, correct? All right, and the area is how much per square whatever, right, is inside of the figure. And what is the area of a parallelogram? That's a parallelogram. What is the area? Do you know? Is what? It's base times height. Very good. Okay, so let's take a look at a parallelogram. Okay, first of all, either one can be a base. Okay? Either one can be a base. So if this is a base and this is a base, so they're the same, then this is the height. Correct? All right. But let's draw the same thing, all right? And this is what a lot of students don't understand. What if this is the base and this is the base? Okay? All right? So the height then, I'm going to put this B over here. The height then is to this base, right? And I want to go from this side somewhere, and it has to be perpendicular to this base. Okay, so it has to be at a 90-degree angle. Maybe I should put it back out there. Okay, so let's say the height is this straight distance, isn't it? So it forms a 90-degree angle with this. So does that look like it forms a 90-degree angle with that? Okay, and it goes like this. This is 90 degrees and this is 90 degrees. So this is the height. Okay? You can draw the height anywhere. For example, I could extend this out, and if this was the base and that was the base, I could draw the height out here. Okay? The height just has to be that perpendicular distance between the two bases. Do we understand that? Okay? It's awesome if it works out great. Okay? Let's take a look at this particular problem. All right, let's say that I have this parallelogram. Oops. Those are really hard to draw. Okay? And I have, this is 10 inches. And the height right here, right there. Now the base is on the side, isn't it? Okay? This is 4 inches. And this length right here, do you see it drawn? It's kind of a rough draw. Is 3.5 inches. What two numbers do I multiply together? What two numbers do I multiply together? 10 and 3.5. How does she know that? Why not 4 and 3.5? Why not 4 and 3.5? If you want to look at this picture, it's on page 726. It's at the top of the page. Because my picture doesn't do a lot of justice, so the height 3.5 is the height between which two sides? The 10 and the 10 or the 4 and the 4? The 10 and the 10. It's perpendicular to the 10 and the 10. Therefore, I have to take 10 times 3.5, which is 35 inches squared. Does that make sense to you, Nelson?
Yeah.
All right. Okay, so let's take a question number 2. Let's have a parallelogram that looks like this. All right. And this comes straight down. Okay. And this angle right here is 30 degrees. We have this distance here is 12 meters, little m, and this is 32 meters. Okay. Now, what are we missing? If we want to find the area of this parallelogram, what are we missing? The height. Okay, can we find the height based on the information that we're given? How do we do that? That is a 12 meters. It's a 30, 60, 90 triangle. And which side do you have across from? You have across from the 30, correct? All right, so is the height across from the other one? It's across from the 60, correct? So how do I get 12 and get that length? What would I do based on what we did before? Do you agree with her? She says take 12 times the square root of 3. Yes. You take 12 times the square root of 3. So this is 12 times the square root of 3, this side right here. And that's your height. So my area equals 32 times 12 square root of 3. Now, plug that in your calculator. And to the nearest 10, tell me what that is. So you're going to take 32 times 12 times the square root of 3. 665 point what? Nearest 10. 1. What's my label? Meters squared. Okay? All right. So we see how to do that. So we're actually using a 30, 60, 90 triangle to solve for that. Any? Okay? You got it? Let's do a number 3 on this. Okay, so let's take a parallelogram that looks like this. Okay, I'm telling you it's a parallelogram. Okay, there's the height. Okay, this whole thing right here is 15 millimeters. Okay, so that bottom base is 15 millimeters. Okay, this is 45 degrees. And this is 8.5 millimeters. Okay. What am I missing in order to find the area? The height. I'm missing the height, aren't I? Okay. What value could I use to find the height? What's that? I could use the 45 degree triangle and use what value? 8.5. And 8.5 is what? It's the hypotenuse. All right, so now I want to show you this. I'm going to take 15 times 8.5 divided by the square root of 2. Is that correct? Guys, should I rationalize that? No, you don't have to. Because you're going to multiply it anyway. So you're going to take 15 times 8.5 divided by the square root of 2. Now I like to put it in parentheses so I know what I'm doing. Can you give me this to the nearest tenth, please?
180.3.
You got 90 point what?
180.3.
Okay.
I got 90.2.
I think the answer is 90.2 millimeters squared. Okay. Help her out.
You got that right. What did you do wrong? I didn't do anything wrong. I think you multiplied. You didn't divide.
Okay. All right. You got to divide. Okay. You want to try it? That's what we got. Okay. All right. Any questions about that? All right. So now, if you take a parallelogram, let's take a parallelogram, this parallelogram, and its base is this, right? And its height is this, correct? That's the height, right? All right. And you cut this, and so the area of that is what? The area is base times height, right? Okay. And you cut it in two. Tell me about the triangle's form. It's 1/2 of the parallelogram with the same base and the same height, right? Isn't it? And these two triangles are congruent, aren't they? So that tells us what's the area of a triangle? 1/2 base times height. Okay? We just have to make sure we get the right height and the base, right? Could I also say that it's base times height divided by 2? Could I also say that it's 0.5 times base times height? I can do all of those things, correct? You have a question? All right. Okay, so let's say, I'm on number 4, right? And we kind of, let's say I have a triangle that looks like this. Okay? And it's 19 inches from here to here. Okay? And then from here, I'm gonna pull this out and I'm gonna drop this down. Now what did I do there? What did I create?
You made a parallelogram.
Well, no, I didn't.
Oh wait, no you didn't. My bad.
This is 30 inches. What is that? What is that value? That is the height. That is the height of this triangle. You understand that? It's from this side to that point is the height. This is still the base, right? Okay, this is 41 inches. Okay, that's 41 inches. Now, I'm going to ask you two questions. I'm going to ask you what the perimeter is, and I'm going to ask you what the area is. Okay? Perimeter is around it, right? So we have 19 plus 41, but we need this length. How do I find it? Oh, I forgot to give you something else. From here to here is 27 inches. That's kind of a big deal. Can I find this length? How? Pythagorean theorem. Using what? 27 squared plus 30 squared. And that equals this side square root of that, right? Well, we'll call it x. We'll call it x squared. Do you understand that? All right, now, what is 27 squared? 729. What's 30 squared?
900.
900. So take, tell me what 900 plus 729 is.
1,629.
29. Okay. Now, so that's x squared, right? So what's x? The square root of that, right?
Mm-hmm.
Now I'm going to show you how to do this so we're accurate. Okay, we want to be accurate. So the perimeters, we're going to have to add up these sides. 19 plus 41 plus what? 1629. I don't want you, you can do the square root of 1629 first and then add 41 plus 19, correct? All right, would you do that, please, for me? And tell me what you get to the nearest tenth. 100 what? 100.4 inches. And remember, it's just inches. Why?
It's not area.
It's not area. Melcha, do you understand everything we did there?
Yeah.
Okay, so now the area is 1/2 base times height, right? So I'm going to go 0.5 times what?
Times
19 times
30.
30. 30 is not even in the triangle, is it? But it is the height, isn't it? So what is 0.5 times 19 times 30 to the nearest tenth? It'll come out even.
285.
285 inches squared. Make sure you watch your labels. Okay? Do you see how to do a triangle? Okay. Do I need to do another one of those? Or are you good?
We're good.
All right. So let's take a look at number 16 on your assignment. Let's do it over here. 16. I'm on page 729. We're going to do 10 through 22. And you have what they call a tanagram. Now, a tanagram is made up of geometric shapes, and what you try to do is put them together to form a square or a rectangle. Sometimes it's a rectangle. Most of the time it's a square. So you see the tanagram on page 729. It says the tanagram is a 4-inch square. So you put those triangles and those parallelograms together, and you come up with a square that has a side of 4 inches. And we're going to do A. Okay, it says find the perimeter and the area of the purple triangle round to the nearest tenth. Okay, the purple triangle, correct? So let me draw just the purple triangle. Looks like this, correct? All right. And this is 4 inches all the way across, right? Okay. So that would be a nice base, wouldn't it? Yeah. But that's about all we know. If I draw this height right here, this forms two right triangles. Are those two right triangles congruent?
Yeah.
Yeah, they are. So this now becomes 2 inches, right? And that's 2 inches, is that correct? Okay, what kind of triangle is formed by that?
45, 45, 90.
Is it? And why?
Because they're equal.
Because the sides are equal, aren't they? Therefore, this is a 45-degree angle, right? Making this a 45-degree angle, right? So you have a leg, right? What's your height? 2 inches. Okay. Well, what's the this length?
2 square root of 2.
It's 2 square root of 2, right? So the perimeter is, now remember, we want to find perimeter and area. So the perimeter is what? 2 plus 2 plus 2 square root of 2. All right, would you do that on your calculator, please? Sorry, I can't keep that straight.
Don't you need to? Why don't we use 4?
Oh, you're right. All right. So this is 2 square root of 2, and the whole thing is 4. Thank you for yelling at me. Okay. All right. And I do feel like you yelled at me there. I felt attacked. Okay, so we're gonna add 2 square root of 2 plus 2 square root of 2 plus 4, right? To get the whole thing, because this is 4. Now you could add these two together and get 4 square root of 2 plus 4. It doesn't matter. All right. What did you get for the perimeter?
8.4. I don't know that's right though.
I don't. Did you? Wait a minute. I don't think I'm going to get what they got. 9.7. That's what they got. 9.7.
I got that.
Okay. 9.7 inches. Hold up and make sure everybody got that.
2 square. Now I got that.
All right. Okay. We got that? All right. Well, good. Now let's find the area. Phew. The area is the base, which is what? 4 times the height, which is 2. And then we got to take it times 0.5, right?
4.
I should have done that. So 4 inches squared, right? Should have done that first. All right, now you're going to do the blue triangle, or the blue parallelogram. I'm sorry, the blue parallelogram in B. All right, can you handle that one, or do we need to look at it? Maybe we better look at it. The blue parallelogram. I guess that's blue.
That does not look blue.
I know.
I would say
I know, I'm a little confused about blue too there, but I think it's on the right side. Is that correct? The blue triangle?
Yes.
All right. So how far is it from here to here? How far is it from here to here?
Oh, that. It's on the right side.
It's on the right side.
It's lavender. It's kind of grayish.
Okay, all right. We can discuss the color. I'm asking you, how far is the base from here to here? 2 inches. Everybody agree with that?
Yeah.
It's half of that bad boy, right? Okay, so this is 2 inches. Okay? But we're going to have to find this length, aren't we, to find this?
1 1.
How do you think it's 1?
Because it's 1 boxes.
It's what?
If you look, yeah, if you look at the boxes.
Oh, it is 1. All right. All right, just hush, calm down. Now wait a minute. This is 1 inch from here to here. This is 1 inch.
Yes.
Okay, but that doesn't tell us how far this is.
It's 1 box.
It can't be, because this is 1 inch, so that's longer.
Oh, I thought you were talking.
We're talking about the line, not the hypotenuse.
Oh, no. Okay. All right. So what I get the hypotenuse is what?
1 square root 2.
1 square root 2. Thank you. Phew. Oh, no wonder. Okay, so this is a square root of 2. So my perimeter is, there's 2 of those, so there's 2 of these. So that's 4 plus 2 square root 2, right? Which is what? 6.8 inches. Okay, now the area then is what? 0.5 times, what's your base?
2.
2. What's your height?
1.
1.
Why'd you do
0.5.
Why'd you do 0.5?
Because it's so half.
Oh, you're right. Oh, no, it's a parallelogram. There's a lot of fighting going on in there. All right. So 2 times 1. So how big is it?
2 inches squared.
2 inches squared. Not a big puppy, is it? All right. Yeah, that was crazy. Wow, just a lot of tension on that problem. Okay, page 729. I better get out while the going's good. 10 through 22. It is due Monday. Monday. Now look, well, I'll talk after the camera's off, all right, about the future.
They're gonna listen
Okay.
to this video and be like, what the heck?